Hi everyone, this is Udushi. Welcome back to my channel. In this video, I'm going to show you how you can get started with machine learning using already existing packages in Python. There are a lot of packages that contain material databases from Material Project and many other databases. So I'm going to show you how you can extract structures from those databases and then apply your machine learning algorithms and do whatever you want to do with the research problem. So I have already shot while I was trying this thing. So in my audio, I'm just going to make you run through it, what I really did. So first of all, I'll start with how I got the structures from Material Project in Jupyter Notebook in my laptop, and which packages I'm using, and what commands mean. And then I'm going to run a small algorithm and compare it with the make a comparison between two structures just for the sake of it. So it is not a very accurate machine learning thing that I'm doing. The purpose is just to show you how to extract structures from the databases. The purpose of this video is not to tell you about machine learning algorithm. I'm not going to differentiate. I'm not going to talk about which algorithm I'm using, because in this video, I'm just randomly applying an algorithm. So just keep that in mind. And how do you install these packages in your laptop? I'm going to show it in the last towards the end of my video. So I did a recording while I was installing these packages in my laptop. So there you can see how I installed all these packages in my laptop and got started with it. So let's get started. So what we have here is I go to the directory and I activate my conda environment of Python 3.8. So that's where I install all the packages. And how I install all these packages, how to activate this conda environment, I'm going to show towards the end. So now I want to open my Jupyter Notebook. Okay. So all the packages are installed in py38 environment. Okay, so this is how the Jupyter Notebook looks like. I already have a notebook where I already tried something, so I'm going to open a new one, and I'm using Python 3.8 as you can see, and I'm going to save it first. So you can save it to some path, because in my terminal I'm already in a path where I want it to be saved, so I'll just use the name. And yep, so now I import Python packages that I want to use. It includes NumPy, pandas. Okay, so Pymatgen is a very important package, and this is the Python package for materials and genomics. So this is what you need to install. I can give you a little bit of brief about this package right here. Okay, so I get this package. Yep, Python materials genomics, open source Python library for material analysis. So you can do a lot of things in there. Okay, you can run optimization, create structures, extract structures. So for installation, you can, after you have installed your conda, you have created your Python environment, you can use this command to install Pymatgen. Some packages need to be already installed before you install Pymatgen. I'll show you towards the end of this video how I did that. Okay, so like I said, you can do phase analysis, electron density analysis. So this extension, Mat project, MP-Rester, is an extension of Pymatgen that is an interface with materials project. Okay, and you need an API to enable or get access to material project. How can you get this material API? You need to be a registered user of material project. Okay, so I need another package which is called Matminer. Now this Matminer is another material database. Okay, it's a Python library for a lot of material databases, not just material project, but a lot of other databases as well. So this is the command you use to install it after you have installed your conda. Okay, so I imported them. So I'll just try to see what all datasets are available, okay, in Matminer. So matminer.dataset, import get available datasets. So here all the name of dataset and their explanation. So you see there are numerous datasets that are contained in Matminer. You have, and their explanation is given here. You have bulk metallic glass. You have phonon. Yes, this MP all 2018. It is a complete copy of material project database as of 2018. So it contains all the structures of all the materials that are present in material project. So here it's just the name, okay, of all the databases. So what you saw up was the explanation, and these are just the name. And I can load any dataset out of it using load underscore dataset command. Okay, I'm saving it in df data frame, and I want material project database to be loaded. And the problem is material project, I did it before, it contains about over 88,000, close to 90,000 structures. So it is going to get all the information, including energy, all the DOS related information that is present in the material project in this command. So it is getting all the information for 90,000 structures. So it's huge. So first of all, it'll store your data set somewhere in the where your package Matminer is stored. Okay, Matminer dataset, and it's going to take some time, and it's going to get a lot of structures. But because I'm just showing you here, I don't think we need to work with such a huge data set, but you can try it yourself. Okay, you can keep trying, and you can keep whatever you need. I just showed you how you can get any data set, entire data set. But when you're doing a machine learning problem, you most definitely don't need the entire data set which contains all the elements. You mostly need specific kind of structures. So I'm going to stop this, and yeah, and I'm just going to show you another way to extract. So using MP-raster, so I'm going to extract only carbon based structures. So this here is the API key that I was talking about earlier that you need. So that's how you use MP-raster. You need API key for your, so you need to have access to materials project. Okay, so you can do that by logging into materials project, and you can do that by going to this link here, materials project, and you can then create your key. There'll be several command, like directions how you can do so, and paste it here once your key is generated. So I already did it for my system. Okay, and so I call all the carbon based structures and properties. So let me show you. Let's just go to material project website. So here how you can create API keys. So you can log in, and while logging in you can click on generate API key and get an API key specific to you for your usage. Okay, so I just had something for myself, so I'm getting all the carbon, element carbon, all the structures of element carbon, and which contain only one element, which is carbon. So you can have carbon dioxide, carbon oxygen, carbon other structures, but I want the structures that contain only carbon. So I'm going to go on the website of material project and log in. So this is how it looks like. So I put carbon there and I do search. So I get all the structures of carbon, only carbon. There are about 59 structures right here. So, yep. So this is what it looks like. This is a carbon. Let's check another one. Oh, this looks like graphite. Yep, this is graphite. So these are unit cells, okay? You have to understand that these are periodic. So when you repeat them in the dimensions, it will create a graphite structure. So I'll run this command. So what I'm getting out of material project is material ID, energy per atom, and structure, which is Cartesian coordinates. And I'm going to save this information of for all the carbon atoms, some properties in a short C, and then I'm going to save it as a data frame named DFC. Okay, so DFC contains material ID, and we have about 58. Okay, this is 59 because it is starting from 0 right here. So we got all the structures that we just saw in material. So we got energy per atom, material ID. So let's see. Let's look for MP169. Oh, there you have it, MP169. So we got all the structures. That means, okay, the Cartesian coordinates, the energy per atom, they're just a little jumbled up. So they are not exactly in that sequence the way you find on material project. So now these are Cartesian coordinates and you cannot use it as an input to any machine learning algorithm. Why? You can see my other videos. So I'm going to convert them to a featurizer. Okay, what are featurizers? Again, I've explained it in other videos. So you convert structure to certain features. Okay, these are the features that represent your structures, and then you enter it to any machine learning algorithm to predict a property, and you can have numerous. Matminer contains ability to convert your different information to different kind of featurizers. You can convert band structures. You can convert composition to any featurizing, like any feature labels. What I'm looking for is structures because I want to convert Cartesian coordinates, the structure. So here they are, generating features based on material's crystal structure. So we have bond fractions, bag of bonds. Okay, I'm explaining all of these in my other videos, some details about them. Coulomb matrix, sine Coulomb matrix, they're quite accurate ones. Okay, so you can use these. You can play around with these as you feel like. I'm just going to show you how to use Matminer. So for that purpose, I'm going to use a very easy one, XRD power pattern. So it's a 1D array representing powder diffraction of a structure. So I hope you know what XRD is. It is a characterization technique for crystals. Okay, so there are other features you can use, whatever you like, and play around with it. So I am getting XRD powder pattern as XRD, and I'm going to see how many labels it will create, features. So it will convert my structure into about 128 because it is starting from 0. So 128 features. So now I'm going to convert structure column from DFC to XRD. And now this conversion is going on, and let's print. So you see in my DFC, along with material ID, energy per atom, structure, new set of columns are created containing XRD peak for the structures. So this XRD 1D array is generated from the structure, that is from the Cartesian coordinates that are present for all the structures, for all the 59 carbon structures I get XRD. Yes, 131 columns. So now I want to work towards machine learning. So I want to have energy per atom as my property to predict as Y. Okay, so I'm going to extract energy per atom values from DFC as Y. I'm going to run it, and you see I got all the energy per atom values for all the 59 structures in Y. So this is going to be my Y in machine learning, something that we will predict using machine learning. Okay, now your database contains a lot of other things. We need to drop them. So we'll use Panda's drop feature. We'll drop material ID, energy per atom, and structure from this data frame. Now only XRD is left in my X. Okay, so this is going to be input for my machine learning. Thing is, I used structure to create XRD. Okay, I used energy per atom to get Y. So they were useful up until now. Now I don't need it. Machine learning algorithm will not read an input like this. I only need to input the features XRD. So now I'm using random forest regressor just randomly, okay? I'm going to fit X and Y into it. I'm just doing it randomly. You can use any other method. I'm just going to do it for demonstration. So, like cut me some slack there. Now I'm going to predict. So RF is containing my ML algorithm saved, trained. So I'm going to predict values on X and plot them as blue, and the ones that were originally as red, and I'm going to calculate root mean square error. Okay, so yeah, this is again very random thing, just doing it. You can create a neural network using TensorFlow, Keras, or you can use any other regression based upon your problem. Okay, so this is what it looks like. So RMSE value is 0.223 EV per atom, quite not accurate. Obviously, what can you expect? So red ones are the actual values, blue ones are the predicted values here. So this is not quite accurate, but once again, I'll repeat it. The purpose of this video is not to help you understand machine learning algorithms, but just to show you how you can extract materials from databases, material databases specifically, how you can use a featurizer. And secondly, this is 1D array. So crystal structure is getting converted to 1D array in Featurizers. You can use any other featurizer. It will change the accuracy. You can use any other machine learning algorithm. Right here. Now I want to give it a try with different element. How about oxygen? Yeah, but I'll do it in a new notebook. Let's do it in a new notebook. So same way like I did for carbon, I'm going to just get all the oxygen structures. Okay, just randomly giving it a try right here. And since I need only oxygen structures, I will use this setup here. I'll change it to oxygen. I'll get the same things. And I'll save it in as a data frame. I'll change the name to DFO just for clarity, okay? Yep, so I get about 20 structures of oxygen. How many do we have in material project? No. Okay. Yep, we have about 20 structures in material project of O2. So we got all the structures right here. Well, you might be guessing 20 is very less for any machine learning thing to do, but this is just a demonstration. Again, people, okay? So I will same way do the XRD, but it has 128 labels. How do I think 128 might not be sufficient and I want more labels, okay? I want more features. I want this 1D array to be not having just 128 columns but something more. How can I do that? I'll Google this. Okay, so when I Google this, I got this. I'm going to the backend code to understand XRD powder pattern right here. So you can see, and you can get a little bit more idea about how it really works, how you can change some parameters here and there. So this right here, 2 theta range, is, I guess, what's determining the features. So I'll just change it, Just remember, I'm randomly changing it. It's not something accurate. I've not researched what it should be, what it shouldn't be, but I'm just showing you how you can play around with it. But do your own research, okay, beforehand, before you actually use it for any project. I'm not doing actual research right here, guys. So that's why I'm just doing things randomly, just to show. So, yeah, now my XRD will contain about 301 labels. Yeah, 0 to 300. That means 301. So I will convert my structures to oxygen structures to these 300 XRD features, and this is what it looks like. What? You see a lot of zeros. That is because all of these structures are O2, only oxygen, and then just only 20 structures. So I'm not expecting results to be very accurate. What can you expect, So I'll just get the Y's, energy per atom. I'll drop all the unnecessary things. I think I've worked with them. I'll do the exact same thing. I'll save it. Yes, very importantly. Yep, 301 columns. And now I'll do the exact same thing, just the same random forest regressor. I did not research random forest regressor again, people, okay? And so I paste it, I'll do the same thing. Okay, let's do the run, and we have, wow. So RMSE looks 0.153 V per atom, but still these are not accurate. These are just 20 structures. How about I make this XRD label change with the carbon and see. So I will run this. Here I will change 2 theta range to 300. I'm sorry guys, it just keeps scrolling on itself. So I'm going to convert all the XRD structures like all the structures to XRD. So we have 300 features for the structures. A lot of zeros right there. This is not a good sign. Okay, I get all the Y's, I get all the X, and I do the algorithm, and I do the, okay, this is not run yet. I do the prediction. Wow, RMSE increased. Obviously, too many zeros in your data set, not a good sign. Okay, but again, you can play around with these. You can play around with your machine learning algorithm. You can plan your projects accordingly. Purpose of this video was to show you how you can use the Python packages for descriptors and extracting structures from material databases. So use it wisely. Now, in this section, I'm going to just go through how I install these packages. So I recorded it while I was doing it. So I installed Conda, I did Conda list, and it showed me, yeah, I did Conda list, and it showed, after you install the Conda package. So I installed it using Miniforge because I'm using Apple M1 MacBook. If you're using any other, so yes, Conda create -n py38. So this is the name of the environment. So I'm trying to create a Python environment with this name, which contains Python 3.8. So it will install Python 3.8, okay, and it will create an environment with the name py38, and I can activate that environment using this command. So I will activate my py38, and then once I've activated it, I can start installing the packages that I need. So I'll use conda install, numpy I just did. Okay, so here I did conda install TensorFlow right there. Okay, this conda install TensorFlow. So it's a good package for if you're planning to work on deep learning. So like this, once you have installed conda, you can, based upon your system, so I did keras also. So based upon your system, you can go through and see which one will suit better. So for me, Miniforge was best. You might install Miniconda, Anaconda. So I installed pandas just now. Okay, so this is happening in real time, so it's time taking. So yes, you first install the conda, then you create your Python environment. You want to use Python 3.7, you can do that. You want to use Python 3.9, you can do that. You want to use Python, I wanted to use Python 3.8, so I created the environment and then activated it. Now within this environment, I'm installing all the packages. So if I want to work with the, so now you see I'm going to install Pymatgen. So I used pip install Pymatgen. I did not use conda install because it didn't work for me. Okay, I did that conda install Pymatgen, it didn't work on my system. So I used pip install Pymatgen and it did. Sometimes these material databases, they will not install because they need these material related packages will not install because they need pre-installation of other packages, you know. For example, scikit-learn needs to be installed for Matminer. NumPy, so you see here, I'm going to install Matminer the same way, okay, using pip install Matminer command. And you need Python 3.6 or higher for this. You can use conda install or pip install. So I did conda list to see what all packages are there, and I was missing scikit-learn, so I installed scikit-learn now. Okay, this is very important because without scikit-learn, Matminer was not installing. So like this, if you run into any error that Pymatgen or Matminer is not installing, you can see what are the packages you need, you know, need to be pre-installed. So you see the last line, installing collected packages, and Matminer is one of them. So now Matminer is getting installed. So you can check which all packages need to be there, you know, pre-installed, and accordingly you can do so. You can install them before and then install your Pymatgen, Matminer, whatever you need. Okay, so I installed Jupyter Notebook the same way, and it's done. It's done. So I did conda list, and I'm trying to see So I have TensorFlow package installed, as scikit-learn installed. I have Pymatgen installed. I have Notebook, Jupyter Notebook installed, NumPy installed, all of it, Matminer. Yep, it's all there, Jupyter Notebook. So we are good, it seems. So thank you guys for watching.